This is going to be part 2 of our lesson on section 4.1. We're going to look at isosceles triangles. The two sides that are congruent are called the legs. The side that is not congruent to the legs is called the base. And this base is a side that is across from an angle, and that's going to be the angle that's different here. It's called the vertex angle. So this vertex angle is in between the congruent sides. The two angles that match, they touch the base, and those are called your base angles. That terminology is really, really important for when you come across a problem like this. They're going to ask you to find the measures of two sides, segment AB and segment BC, of this isosceles triangle, ABC, if angle A is the vertex angle. So here's what you know. If angle A is the vertex angle, and it's an isosceles triangle, then we know that these two angles are the base angles, and those are the ones that match. And if those are the base angles, then this is the base. So if this is the base, these are the legs. So 5 times a number minus 7 needs to be the same thing as 23. Both of these legs are 23. So we know that 5x equals 30. So 1x equals 6. Now, they wanted you to find the measures of these sides. Well, segment AB, obviously that's 23. Segment BC, that's your base. That's going to be 3 times 6, 18, minus 5. That's going to be 13. We're going to name, then classify the triangle by the side and angle. This particular triangle, we have a right angle, so we know it's a right triangle. Also, notice how 2 of the angles match. That means it needs to be isosceles as well. So we would classify this as a right isosceles triangle. If you wanted to, you could say that it's an isosceles right triangle. Either way is acceptable. Now, notice the 3 angle measures, 45, 45, 90. This is your right isosceles triangle, and there's only one in the world that has these angle measures. You can't have a right isosceles triangle with different angle measures. You got to have the 90, and then the other 2 need to add up to 90 as well, but they got to be the same. So that's why this guy is unique. Your right isosceles will always have those measures. Okay, now how would you name this triangle? I would name it triangle FGE. That kind of looks like a little bit of a star there. That's supposed to be a triangle, and I'm making it worse. Here's number 2. Maybe we'll name it first. Triangle ABC. What kind of triangle is it? Well, all of the angles are less than 90, so it's acute. Also, all of the angles are the same. So that means all the sides are the same. So this is an acute equilateral triangle. Again, this is the only type of acute equilateral triangle in the world. 60, 60, 60 are the measures. If it's equilateral, they all have to be the same. 60, 60, 60 adds up to 180. And they're all acute angles. They can't be anything different. So you cannot have an obtuse equilateral. That type of triangle does not exist. If it's equilateral, then all the angles are the same. You can't have 3 obtuse angles in a triangle. That does not exist. Likewise, you cannot have a right equilateral triangle either. Because if you did, all the angles would be the same. And if there's a right angle, then they'd all have to be right angles. The only equilateral triangle in the world is an acute equilateral. The angle measures must be 60, 60, 60. These two types of triangles do not exist. We'll name this triangle, triangle ZYX. I notice one obtuse angle, so I'm going to say this is an obtuse triangle. I also notice that all of the angle measures are different, so it's scalene. Obtuse scalene or scalene obtuse. Now, this triangle is unlike the last two examples because you could have lots of different types of obtuse scalene triangles. You could make this angle anything bigger than 90, and you can adjust these ones as long as they don't match. You could have a bunch of different examples. So lots of these exist. I'm going to name this triangle MLN. That's its name. Now, how would I classify it? Well, I notice there's a right angle. And I also notice that all of these angles are different. So that means all the sides are different. So it would be a right scalene triangle.